Okay, good morning all. Last class we have discussed some algebraic structures which is used in cryptography, mainly that uh, group, ring and field, and finally he concluded with that Galois field. Today we can have some discussion on some basic ideas prior to that, going to the channel encoding. Okay. We have already studied that source coding, and next we will have to consider that channel encoding. Initially, we have discussed about the that basic block diagram of digital communication system, that data communication system. That two important elements are source encoder and channel encoder. It has specific functions, and we are after that channel encoder part. There is a that source encoder part. It comes that channel encoder part. The basic function is for a reliable transmission of information over the channel, and such different channel encoding methods are widely, we can say, error control coding. That is, its function is in order to control the error. uh, Error control means we will how with that code we can detect the error occurred during the transmission through the channel, and also in some cases we are able to correct that error occurred during the transmission through the channel. Okay, that is error control coding. And basically we can say in error control coding we are adding some redundant symbols to the transmitted information. That is, source encoder output is there. This initially there is a source of information. Its output is encoded using any of the coding mechanism. Then that output which is coming out of that source encoder, some extra bits, we can say some check bits. That is that generally we can say redundant symbols, redundant bits are added to that source encoder output. For the channel encoder output will be that source encoder output plus some redundant bits, redundant symbol. And we can say that two basic objectives at the receiver are error detection and error correction. That is, we have generated some source code as information source is there. It is given to a source encoder. It is coded in order to get maximum efficiency. We have studied that code efficiency, and we have generated a code, and it is transmitting through the channel. There is a chance of occurring error while it is traveling through that channel. Therefore, that error occurred must be detected. This at the receiver, error must be detected, and if the error is detected, it will have to be corrected. Therefore, we can say error detection and error correction occurs at the receiver. Error detection and correction. Okay, initially we can consider an entropy coding. That is, which is a source. This source coding we have already studied. That is, there are different symbols S1, S2, S3 and S4. Its probabilities are given as 1 by 2, 1 by 4, and S3, S4 symbols have the probability 1 by 8. It is, symbol probabilities are given, and here a Huffman coding method is used, and we have generated the code as S1. The symbol S1 is source coded That is source encoder output is 0 corresponding to the symbol S1. S2 is encoded as 10 and S3 110, S3 111. It is the Huffman code obtained corresponding to the given symbols whose probabilities are given. Based on that, by making use of that probability, we have generated the Huffman code. And here we have already studied this, how we can generate the Huffman code. It is a variable length code, prefix code, uniquely decodable code, etc. Instantaneous code, all we have studied. Anyway, it is the corresponding code, Huffman code generated. And once if we calculated the efficiency of this code, we can see it is 100%. That is, here that L, the average code length is 1.75 minutes per symbol, and it is same as that of the entropy of the source. Therefore, h of s by L, that gives that efficiency is 100. Okay, that is, here average code word length and the entropy of the source is same. Therefore, efficiency is 100%. Okay, this is we have already studied. That is, once probability of symbols are given, we are able to generate the code and able to calculate the efficiency. Then consider here the transmitted symbols are S3, S4, S1. These the symbols transmitted through the channel. Okay, this S3, therefore corresponding code here is 110, therefore 110. Then S4 code is 111, 111. Then S1 is the next symbol transmitting, therefore 0. Therefore that sequence, that binary sequence will be 110, 1110. Is the transmitted sequence. Okay, suppose a 1 bit error is occurred during the transmission. That is, for example, first bit 1 is changed to 0. That is, a single bit error is occurred when it is transmitting through the channel. Okay, here the transmitted sequence is S3, S4, S1, and the case is uh, a single bit error is occurred. That is, first bit an error is occurred. Then can you say what will be the received sequence? How it will be encoded at the receiver end? If it is the receiver, uh, uh, transmitter sequence is here, it is, and 1 bit error, first bit is in error. Then can anyone say what will be the received sequence? Please someone type in the chat. It is S3, S4, S1 is the source output. It is encoded and it is transmitting through the channel, and an error is occurred in the first bit. Therefore the received sequence is 0 1 0 1 1 1 0. Then how it will be decoded? Can anyone say, please? Someone please type in the chat. We have S1 is 0, S2 is 10, S3 is 110, S4 is 111.
S1, S2,
Yes, yes,
S4, S1.
yes, you are correct. Okay, this will be decoded as S1, S2, S4, S2. It is, we have transmitting a binary sequence which is 100% efficient code. Okay, that output of the source encoder is a 100. Hello.
ലാസ്റ്റ് S2 ആണ് വരുന്നത്, S1 ആണ് വരുന്നത്.
Sorry, it is S1. Sorry, I will correct. It is S1. S1, S2, S4, S1. Okay. Uh, that is here. It is not the transmitted sequence. Actually, it is transmitted S3, S4, and S1, and some error is occurred. A single bit error is occurred, and that is a 100% efficient code is transmitting, but there is an error in the received sequence. Okay, and here there are different therefore we will have to take measures to uh, receive that sequence properly, that is without error, in order to overcome that error occurring during the transmission through the channel. And here we are, this Huffman code is a variable length code, and in some cases that fixed length code and may do some error correction. We can see that. And then the exact method we are using is termed as error control coding. That is different coding mechanism in order to that error correction. For the detection and correction, some coding is done. That is, output of that source encoder is given to a channel encoder, and a channel coding, it is termed as channel coding. Okay, and here we have already studied this particular block diagram. That is, source encoder and channel encoder are the part of that data transmission system. That is, output of the source encoding is given to that to a channel encoding. And next we are going to study different channel coding mechanism. And initially we can have different discuss about that different types of codes. And first of all, we can classify into block codes and convolutional code. Block codes and convolutional code. And in block code, in general, we can say uh, it consists of a n number of bits in one block or code word. That is, that final code word generated will be a n bit length code. And out of these n bits, k will be message, k number of bits will be message bits, and n minus k redundant bits. That is, by taking k message bits, we are generating some redundant bits, extra bits are added for generating that code word. That is, code word corresponding to a k message bits. That is, if we take it as that message as u1, u2, u3, etc., uk, that is, you represent that message which is having k message bit. Then we are generating another a code word corresponding to that u, take it as v. Then that v is equal to, we can say, v1, v2, v3, etc., up to vn, n number of bits in that code word. In general, we can say nk block codes. This is the general structure we are representing, small letter n and k. nk block code. In this, it means k number of message bits are taken, and corresponding to that k message bit, we are generating a n bit code word. And it will be of different types, we will see later. In some cases we are not able to distinguish that message bits and check bits. It will be in a mixed manner. In some cases, that initial part will be the k message bits, then that n minus k bits will be the check bits, that redundant bits. Or some cases initial part can be that check bits, then the k message bits. Different format is there. That is, if we take it as a 7-3 block code, 7-3 block code means corresponding to each 3-bit message, we are generating a 7-bit code word. Okay, that is extra 4 bits are added. The purpose is error detection and correction. It is, that is here that message which are the output of that source encoder. Here nk, that is the general structure we are using, nk block code. For example, if it is 6 3 n equal to 6 and k equal to 3, it means corresponding to each 3 message bits we are generating a 6-bit code word. For if we are considering that binary sequence 0 0 0 0 0 0 1 up to 1 1 1, there are 8 combination there. Okay, 8 possibilities for that k message bits, starting from that 0 0 0 to 1 1 1. Then there will be 8 code word by adding 3 extra bits. If it is a 6-3 block code, that is that code word corresponding to each 3 message bit will be a 6-bit code word, like that. For here we are adding uh, redundant bits, extra bits, check bits, n minus k number of extra bits. uh, that's about that block code. That is, we take k number of message bits, and corresponding to that k message bits we are generating a n-bit code word by adding n minus k redundant bits. We can say it is as check bits, that are redundant bits, check bits. It is that extra bits, they are check bits. We are making use of that check bits for the purpose of error detection and error correction. We will see uh, how we can uh, detect that error and how it is correcting that error. And that is the general structure of a block code. And another one is convolutional code. It is a discrete time convolution of input sequence with impulse response of the encoder. It is for the encoder, it will be a there will be a impulse response. You know what is meant by impulse response of a system. And the message sequence is continuously given to that encoder, and the output, the code is the discrete time convolution of that input sequence with the impulse response of the encoder. Therefore in that we can see a particular output corresponding to a message bit depends on the previous input also, like that. It is we will you know how we can calculate the convolution of two sequence. And here the code is a discrete time convolution of input sequence with the impulse response of the encoder. Okay, we will see that convolutional code and block code in detail, and different block diagram representation, and how we can calculate the impulse convolutional code corresponding to a input sequence if the impulse response of the encoder is given. Okay, anyway, we can broadly classify this channel coding techniques or that error controlling as into two: block code and convolutional code. We will study this block code and convolutional code in detail. And another classification is linear code and non-linear code. Linear code means if the two code words are added by modulo 2 arithmetic. And we are discussing only about the binary code, that is only 0 and 1. Therefore it make use of that mode 2 addition, that is 0 plus 0 0 0 plus 1 1 1 plus 1 0. That is that modulo 2 arithmetic. And uh, take a block code, a 6-3 block code corresponding to each 3-bit message, we have generated a 6-bit code word. Then there are 8 message combination, and corresponding to each message there will be 8 code word. Okay, if we take any 2 code words and add it by mode 2 arithmetic, then the output of that addition, that will be another code word. That is, if you take 2 code word in that 8 code words, then addition of 2 code word give another code word which is in that set. There are 8 code word, and if we add 2, അതായത് ഒരു 6-3 ബ്ലോക്ക് കോഡ് ആണെങ്കിൽ ഓരോ 3 ബിറ്റ് മെസ്സേജിനും കറസ്പോണ്ടിങ് ആയിട്ട് 6 ബിറ്റുള്ള കോഡ് വേർഡ് ജനറേറ്റ് ചെയ്യുന്നു. ആ കോഡ് വേർഡ് സെറ്റ്, ദർ ആർ 8 കോഡ് വേർഡ്സ് പോസിബിൾ. ഇഫ് യു ടേക്ക് ഏതെങ്കിലും 2 കോഡ് വേർഡ് എടുത്ത് ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ കിട്ടുന്നത് ആ 8 സെറ്റ് കോഡ് വേർഡിലുള്ള ഏതെങ്കിലും ഒരെണ്ണം തന്നെ ആയിരിക്കും. ഓക്കെ, ഇഫ് ദ 2 കോഡ് വേർഡ്സ് ആർ ആഡഡ് by mode 2 arithmetic, then it produce third code word uh, in that code. Okay, that is, then we say a linear code. Non-linear code, addition of non-linear code word. If we take 2 code words, it does not necessarily produce the third code word. It is not there in that set. Okay, that is that linear code and non-linear code. 2 കോഡ് വേർഡ് എടുത്ത് ആഡ് ചെയ്ത് കഴിഞ്ഞാൽ ആ സെറ്റ് തന്നെയുള്ള വേറൊരു കോഡ് വേർഡ് കിട്ടുകയാണെങ്കിൽ വി സേ ഇറ്റ് ഈസ് എ ലീനിയർ കോഡ്, അതർവൈസ് എ നോൺ ലീനിയർ കോഡ്. ആൻഡ് നെക്സ്റ്റ് we are going to see in detail linear block code. Actually, linear block code, that is which satisfy that linearity condition and which is a block code. Okay, anyway, here under this and error control coding, we can have block code and convolutional code, and next is linear code and non-linear code. Okay, then before going to that details of that error linear block code and linear block code and convolutional code, we can have some simple examples of this error control coding. That is, each message bit, that is 0, and 0 is represented by 3 zeros. It is according, we can say 0 represented by 3 zeros and 1 is represented by 3 ones. That is a triplet code. 0 is represented by 0 0 0. That is code word corresponding to 0 is 0 0 0, and code word corresponding to 1 is 1 1 1. That is 2 redundant bits in every message. That is, we have added 2 extra bits to each message. Okay, we have generated a code word by adding 2 extra bits, 2 redundant bits, and generated that code word here. And at the receiver end, the decoder checks the received triplets and take a decision in favor of majority of the bits. Okay, okay, here at the receiver end, it take 3 bits at a time, and if it is 0 0 0, it is decoded as 0. If it is 0 0 1, this in that 3 bits 2 0 and 1 1, then it take a decision in favor of that 0. If it is 1 0 0, first bit is 1, next 2 bits are zeros, then also it take a decision in favor of 0. That is, decoder check the received triplets and take a decision in favor of majority of bits. That is, if there are 3 bits considering at a time, Then if two zeros are there, then it take a decision in favor of zero. Similarly, if there are two ones in the received triplet, then it take a decision in favor of one. That is, take a decision in favor of majority of bits. Then can anyone say if how much what is the chance of error detection here? There is any chance of error detection? Please, someone say. ഇത് സീറോ എന്നുള്ളത് 3 സീറോ ആയിട്ട് കോഡ് ചെയ്തു, 1 എന്നുള്ളത് 3 1 ആയിട്ട് കോഡ് ചെയ്തു, എന്നിട്ട് ട്രാൻസ്മിറ്റ് ചെയ്യുന്നു. Then that is 2 extra bits are added, and at the receiver end it consider 3 bits at a time, and it take a in decision in favor of majority of bits. Then can anyone say that chance of error detection there, if it is possible error detecting in that case? No response. എന്തേ ആരും ഒന്നും പറയാത്തെ? Anyone? Audible അല്ലേ? Please say yes or no in chat box.
ഓഡിബിൾ ആണ് സാർ.
ആ ഓക്കെ, പറയുന്ന കേൾക്കുന്നുണ്ടല്ലോ.
ഉണ്ട് ഉണ്ട്.
അപ്പൊ അവിടെ ഒരു സിംഗിൾ ബിറ്റ് എറർ സംഭവിച്ചാൽ അത് ഡിറ്റക്ട് ചെയ്യാൻ പറ്റുമോ? ഇനി 2 ബിറ്റിൽ എറർ സംഭവിച്ചാൽ എങ്ങനെയാ ഡിറ്റക്ട് ചെയ്യാൻ പറ്റുമോ?
സിംഗിൾ ബിറ്റ് ചെയ്യാൻ പാടില്ല.
Okay, that is correct. That is here if a single bit error is occurred, it will it is possible to detect that error. Then only error detection is possible in that case. Okay, we can correct also a single bit error. That is, the message symbol is received correctly if no more than one bit is in error. Okay, therefore here the redundancy in the transmitted message reduces the probability of error at the receiver. It is a simple error controlling mechanism that is representing like this. A code word is generated by adding extra bits, check bits. Then some errors can be detected and corrected. Okay, then in this error control coding has the following aspects. The redundancy bit are called check bits, and errors can be detected and correct with the help of these bits. This we are adding extra bits, which is termed as check bits. The purpose of the check bits is for the detection and correction of the error. Is with the help of these check bits we can detect the error and correct the error. And errors up to a certain limit can be detected and corrected. There is a limit. It is not possible to correct if more errors are occurred. There is a limit, you can say, in error control coding. There is a certain limit to how much errors can be detected and how much errors can be corrected. This we have generated a linear block code. Then we can predict comment about the its error detection capability and error correction capability. If we are using this particular linear block code, we can able to detect up to 2 errors, and we are able to correct up to 1 error. like that. There is a limit. Once we have generated a linear block code, then making use of some parameters of the code, we can comment about its error detection and error correction capability. Okay, anyway, there is a limit how much errors can be detected and corrected. And then the check bits reduces the data rate through the channel. That is, we are transmitting extra bits. Therefore, uh, it reduces the data rate through the channel. That is, here we are adding extra bits as the check bits for the purpose of error detection and correction. Therefore, it reduces the data rate through the channel. Then uh, about different methods of controlling these errors, we can say we can have two types: forward acting error correction, and second one is error detection with retransmission. In forward acting error correction, the errors can be detected and corrected by proper coding techniques. Forward acting error correction is faster, but the overall probability of error is higher. It is here the coding mechanism, the coding techniques. In it, it is possible to detect the error. Once the error is detected, there is provision for correcting that error also. Okay, that is, error is detected by making use of this particular coding. If it is a coding mechanism with that forward acting error correction, once the uh, at the receiver end the error is detected, there is provision for correcting that error in that coding mechanism. This at the receiver end, once the error is detected, it is possible to correct the error. And uh, here this method is faster compared to the other one, but overall probability of error is higher. There is a chance of probability of error. Then in the second mechanism, we will see all the examples for all these. Then in the second one, error detection with the retransmission. Here the case is, in this particular method, when it detects an error, it discards that part of the sequence and requests for retransmission. That is, no provision for error correction, only provision for detecting the error. Once the error is detected in a certain part of that received sequence, it discards that part of the sequence and requests for retransmission. And here this method has lower error probability. That is, it is again transmitting. A retransmission is therefore the error probability is low, but the mechanism overall mechanism is slow compared to the other one. That is the difference. The speed of this transmission, in that forward acting error correction, it is faster, but error probability is higher. Whereas error detection with the rate transmission, it has a lower error probability, but it is slow. And we can classify the error occurring during this transmission, random errors, and it is created to white Gaussian noise in the channel, and it is also termed as independent errors. That is, sometimes these errors are classified as independent errors and burst errors, and these independent errors are random in nature. Therefore, is also known as random errors. It is created due to the white Gaussian noise in the channel, and burst errors generated due to impulsive noise of the channel, characterized by long quiet intervals followed by high amplitude noise burst, such as switching and lightning. Okay, that's about that. Different types of error: random errors and burst errors. And some definition and principle, we're going to that. And we can And one more example I have not included in this slide. That is that error. Some example. One example for that error detection. That is uh, as parity check coding. Parity check coding. You are familiar with that. It is. It can be used for a error detection. That is, if the message is a 3-bit message, we can have 0000010100110011110 etc up to 11. If we are using even parity check code, that is consider a single parity check coding, a single parity check coding, and consider even parity check coding. That is, we are adding an extra bit. Therefore, if the message is 000, then 0 is added. The code word is 4 zeros. Then 001, an extra bit is added. 1 is the that check bit, parity bit. Therefore, the code word corresponding to that 001 is 0011. Okay, I think you are following. That is 00 is the code. Then we are adding an extra bit 0 as the check bits. Then if it is 001, then the extra bit is added as 0011. That is that code word corresponding to that 001 message 001 is 0011. That is that fourth bit is an check bit, parity bit, extra bit we are adding. That is, if it is 010, then the code word we can write as 0101. We are using a even parity check, even parity check code. That is parity check coding. Then next one will be 011 is the message bit. Then we will be adding 0 as the check bits. That is, that fourth bit is the check bits. We can say here the parity bit appears at the rightmost symbol of the code word. Okay, last bit that here we are adding that extra bit as a parity bit. It is at the rightmost of the code word. Okay, that is therefore 3-bit message is converted. That is, if it is a 111, then the code word will be 1111. That is an extra bit in order to make even parity check code. And here we can say this code is capable of detecting all single and triple error patterns. Okay, if you are using this particular coding, this even parity check code, it is possible for detecting, specific detecting all single and triple error patterns. Okay, single and triple error patterns can be detected in this parity code, even parity check code. Okay, then uh, can have on the 5 minutes. Here we are moving to some definition, which is a part of this linear block code and convolutional code. Specifically here, next we are going to next in the next class will be going to discuss about linear block code. Then code word is nothing but that the block of n bits. That is, in that nk for a linear uh, nk block code, that resulting n bits corresponding to that k message bit, that is the code word. And block length, the number of bits n after coding is called the block length of the code. Block length, that n is termed as the block length of the code. And code rate is the ratio of the message bits and the encoded output bits. Therefore, that code rate is nothing but the k by n ratio. K by n is the code rate. Then that Hamming distance, this Hamming distance and minimum distance has some importance. That is, by making use of this parameter minimum distance, we can comment about the, we can predict how much errors can be detected and corrected. And here the Hamming distance mean uh, the two code word, Hamming distance between two code word is equal to the number of elements in which they differ. How many in how much bit position they are different. For example, if the code word 101, if the code word is, if the code word is 10, first code word is 101 and another code word is 110. Here first bit of the two code word is same, second bit is different, third bit is different. Therefore in 2 bit position the code words are different. Therefore the Hamming distance between these two code words is 2. Okay, Hamming distance between two code words is equal to the number of elements in which they differ. Okay, number of elements in which they differ. I think you have got what is meant by that Hamming distance. If there are, if it is a 7-3 block code corresponding to the 8 message combination, there are 8 code word. Then if you take two code word, that is there are 8 possible code words. Then if you take two code word, then in how many bit position they differ. If all the bit position, 7 bit position, they are different, then we can say Hamming distance between that two code word is 7. Two code words in how many bit position they differ. This meaning of that Hamming distance. Then minimum distance, it is the smallest Hamming distance between the valid code vectors, that code word. Consider all the code word and calculate the minimum Hamming distance between all possible. If there are 8 code words, first and second code, we calculate that Hamming distance, first and third. We have got a value for that Hamming distance, like that, first and eighth. Then consider all the possibilities. Then it is the smallest Hamming distance between the valid code vectors. That is minimum distance of the code word. Minimum, that is smallest Hamming distance between all the valid code vectors. And also note that it is denoted as d minimum. That Hamming distance is represented by the letter, and this minimum distance by the by as d minimum. Okay, d minimum. Minimum distance is the smallest Hamming distance between all the possible code words. I think that's all. This we have seen that some introduction to that error control coding, which is part of that channel encoding. Then that classification, block code and convolutional code, a linear code and non-linear code. Then some basic examples. Then some parameters. Out of this Hamming distance and minimum distance are important. If you know the minimum distance, once we have generated the code word, a linear block code, then we are able to calculate this minimum distance, d minimum. Then we can say how much error can be detected and how much error can be corrected using this particular code. That is the significance of this parameter minimum distance. Okay, I think we can stop now. Okay.